What's going on, y'all? Sean of Mass Tutoring here. And today, or in this video rather, we're going to talk about converses, inverses, contrapositives, and biconditionals. All of these are under the umbrella of conditional statements. We're still talking about logic here. But before we get into it, make sure you like, make sure you subscribe, okay? All right. Now, first thing I want to say before I get into all of this is do not be intimidated. Don't be intimidated because the thing is, sometimes what I've noticed, um, even as one who had to take math in school, but especially as a math tutor, is that we'll look at terms and we'll blank. We'll go blank because, oh my gosh, it's a whole lot of words here. There's no way I can know all this. No, it's not true. Just take a deep breath and let's make sense of this. Let's go ahead and define these, understand what's being talked about, and just take your time. And if you need to, watch it again and again and again and again until you understand what these things are. Because it's not as bad as you think. Matter of fact, it's not bad at all. Just understand what the terms mean. Nothing more, okay? All right. So first of all, you see what I have here that all of these are, like I said, conditional or related to conditional statements. So let's recap what a conditional statement is. A conditional statement, I'm just going to write conditional. So a conditional statement is basically what we refer to as if, then. So in other words, if this happens, then that happens. I'll write also if P, if P, then Q. So you remember from what we talked about recently, P is some statement of some kind. So this is just saying if P happens, if P is true, then Q is true. If P happens, then Q happens. Okay. So, kind of a cause and effect thing. We're just being very logical here. So don't think about the fact that this is in a geometry class or anything like that. This is what a conditional statement is. If this happens, then that happens. Okay. All right. So let me make sure that's all I wanted to talk about um here. Okay. Yeah, so a conditional statement, basically, yes, it just says if this happens, then that happens. Um, and we'll leave it there. All right. Now, yeah, we're all gonna have to revisit something a little later. Now let's kind of go ahead into these next few terms that you see here. What is a converse? Now, keep in mind, what is this converse statement? Keep in mind that all of these converses, inverses, contrapositives, and biconditionals, all of these have something to do with conditional statements. So a converse is essentially when the hypothesis, which is the where the P is, whatever follows the if, is switched with the conclusion, which is whatever follows the then. So the converse is basically if Q, then P. Okay. That's all it is. Okay. Now, what is the inverse? So let me see. So let me put this here. Switch the hypothesis and conclusion of the conditional statement. Okay. What is the inverse? The inverse is if how do I say this? If not P, then not Q. Okay. That's what the inverse is. It's all it is the negation. Okay, I'll write that. This is the negation of the hypothesis and conclusion of the conditional statement. Okay. All right. So we talked about the converse, which is switching the hypothesis and the conclusion of the conditional statement. So instead of if P then Q, that is going to be if Q then P. Okay. Next, you have the inverse, which is if not P, then not Q. Okay. And so all the inverse is the negation of the conditional statement, the negation of the hypothesis and the conclusion of the conditional statement. So finally, you have contrapositive. Make sure you can remember these so you don't mix them up. Okay. Now, the contrapositive is like this, and you can probably guess it. If not Q, then not P. All right. So basically, all this is the it is when you switch and negate the hypothesis and conclusion of the conditional statement. Okay. So again, now let me use a different color here so we can use like the symbology, if you will. We'll use blue. So conditional statement, if P, then Q. Okay. Converse statement, you switch the hypothesis and the conclusion. If Q, then P. What about the inverse statement? And with the inverse statement, you negate the hypothesis and conclusion. So if not P, then not Q. And then finally, the contrapositive is going to be switch and negate the hypothesis and conclusion of the conditional. So if not Q, then not P. Okay? All right, good. Okay, let's continue and kind of go a little deeper with these different variations of conditional statements. So if you notice, I've kind of added actual statements for P and for Q. So let's say statement P is that water heats to 212 degrees Fahrenheit. If you remember anything about that, that's the boiling point of water. And so Q is that the water boils. Okay. All right. So the conditional statement, if P, then Q. If water heats to 212 degrees Fahrenheit, then water boils. Okay. So that would be a true statement. Okay. Now, the converse is if Q, then P, um, which is if water boils, then water heats to 212 degrees Fahrenheit. Okay. So that could be true. That could be true, right? So so the reason so it's true in this instance, but if you think about it, it could be some cases where or well, think about it. Are there any cases where if this happens, this does not happen? So I guess, well, really, this does happen to be true in this circumstance, but sometimes we're going to say true and then sometimes. There are sometimes with converses of conditional statements where they may not necessarily be true. And the same is true for inverse. So let's look at inverse. Okay, so the inverse in this case would say if water doesn't heat to 212 degrees Fahrenheit, then water doesn't boil. Okay. So this could be true sometimes because, and again, it's because think about it, like what if water was heated to um beyond that temperature? So, it's a little it's interesting, but like what I'm trying to really kind of like point out is that there can be situations where the converse and the inverse aren't necessarily the same, or they're not necessarily true, if you will, or they're not the same as whatever the truth value for the conditional is. Then finally, you have contrapositive. If water does not boil, then water does not heat to 212 degrees Fahrenheit. If water does not boil, then water does not heat to 212 degrees Fahrenheit. Okay. And so this actually ends up being true. And let's think about why. If water does not boil, that means if it never gets to boiling, then it never heats to 212 degrees Fahrenheit. The contrapositive ends up being always the same as the conditional. Okay. Whereas the converse and the inverse sometimes can be the same as the conditional as far as the truth value, but then sometimes not. I think my example here is okay. You know, so let's put it this way. So let's say I'm gonna give an example that I have here in a book, so we can kind of like probably see a better idea of how this works. I didn't mean to erase that cue, but just watch this with me. Okay. Um, so we're gonna say that okay, a triangle is equilateral, equal lateral sides. So all sides are equal, in other words. And then Q is a triangle is isosceles. Isosceles triangles have at least two sides that are equal um in length. Okay. So conditional. If a triangle is equilateral, then the triangle is isosceles. That's true because a triangle that has all sides equal has at least two sides equal. Okay, good. Converse, if a triangle is isosceles, then the triangle is equilateral. Not necessarily, you see, because in this case, if a triangle is isosceles, that means at least two sides are equal. It could be three, but it could be two sides. So if two sides are equal, then it's not it's not equilateral because that third side is not equal to those two equal sides. You see what I'm saying? So again, you see here that this could be true, but it could not be true. What about the inverse? A triangle is if a triangle is not equilateral, then a triangle is not isosceles. Okay. So think about that. If a triangle is not equilateral, that means if all the sides aren't equal to each other, then the triangle is not does not have two equal sides. Not true. So again, this could be true sometimes, but in that case, you can have a triangle that is not equilateral that is isosceles because isosceles is at least two sides equal. Then finally, you have the contrapositive, which is if a triangle is not isosceles, the triangle is not equilateral. Now that's true for sure. Because if you think about it, if a triangle is not isosceles, that means it has to have at least two sides equal. If it doesn't have at least two sides equal, then it's definitely not going to have three sides equal. Okay. So that's probably a better example of um how these work than my water boiling example. At least kind of showing you a case where the converse and the inverse aren't necessarily equal. Okay, so let's now talk about biconditional. Okay, so biconditional is essentially like so P if and only if Q. Okay. Now, what does that mean? If you were to use the symbology, biconditional basically would be written like so. So you have the conditional if P then Q, and then that is anded with the converse if Q then P. Uh-oh, there we go. So in other words, a biconditional is um true if both the conditional and the converse are true. Okay? So that's why you have P if and only if Q. Okay? So this is what that looks like. So let's show how a biconditional is true only when these statements are each true, okay? Or rather, when both statements are true or false. So let's see. So you got P, you got Q, and then you have if P then Q, then you have if Q then P, and then you have the P if and only if Q, which, as we just said, looks like this here. Okay. Yeah, I'm not doing a pretty chart this time, just for the sake of time. All right. So you got the four situations. You got true, true. Then when P is true and Q is false. Then when P is false and Q is true. And then when P is false and Q is false. Okay. Now, if P, then Q. All right. So if we look at this here, P is true, Q is true, this is true. If P, then Q, if P is true and then Q is false, then the conditional statement is false because it's supposed to be that Q happens if P happens, if that makes sense. This is supposed to this happen Q happens if P happens. Or rather, I guess I need to be careful with the way I say that. Okay. So let's keep on going. If P is false and Q is true, the conditional, let's see if P then Q. If P happens, if P does not happen, then Q happens. Then this could be true. This could be true, because even though P happening makes Q happen, that is not necessarily the only situation under which Q can happen. Okay. But if P does happen, then Q if P if P happens, then Q is supposed to happen. That's why this one ends up being false. But it doesn't work the other way. All right, so if P doesn't happen, then Q doesn't happen. Okay. Um yeah, this could be true too. Because Q can happen Q can happen if P doesn't happen, and then it could not happen if P doesn't happen. You see? I know it's a lot. Just kind of let it sit, let it marinate. All right. So now let's go and look at the converse. Now it works the same. It's a if Q then P. So just kind of look at these here. All right. So this one, true, true. So this is true. If Q then P, that means if Q happens, P happens. Okay. So Q doesn't necessarily have to. This can be true. Now, if Q happens, P happens. So if that is the case, then if Q happens and P doesn't happen, that's false. And then finally, this will be true as well because again, think about it this way. When we're saying if Q then P, we're saying if this happens, this happens. If the Q happens, the P happens. If the Q happens, the P happens. If the Q doesn't happen, the P could or could not happen. That's why each of these ends up being true because Q doesn't happen, P doesn't happen, Q doesn't happen, P does happen. It can go either way. But then if Q happens, P doesn't happen, it's supposed to be that when Q happens, P happens. But in this case, it doesn't. So therefore, it's false. Now, all we have to do is and this value and this value. Remember, for and statements, the both statements have to be true for the whole statement to be true. Okay. So true, 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 false, true, false, true, false, false, and then finally true, true, true. So what we see here is that biconditionals biconditionals are true when both statements are the same. When I say both statements, I mean P and Q had to be the same. So when P and Q are true, the biconditional is true. The other situation where the biconditional is true is when P and Q are false. Okay. All right. So that does it there. This video is a little longer than I wanted it to be, but I encourage you to watch it again and again and again. Make sure that it makes sense to you. And yeah, let me know how this video was for you if you have any questions. Otherwise, y'all have a great day. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.